maintaining the current on the output side, which is,
Right.
pretty extraordinary, but it's not, that extraordinary when you look into the research of these coils. That's what they're supposed to do.
Sure. Yeah. Yeah. I, I've only done voltage impulsing, and I'd like to get into doing proper current impulses, and then to see, because that's I mean, with Evo's last video on this, I mean, uh, he's helped me immeasurably in everything with the circuits and everything. I'll take my hat off to the guy; he's brilliant, and
Mm.
so he's, you know. Um, we're talking about what Tesla's radiant energy really is. It's basically that's a current. It's based on rapid discharge of capacitors, basically.
Mm.
Yeah, he
Impulse,
also
yeah.
said that the CVS cannot produce current impulses, and he's usually right, but I don't understand that at the minute. I'm not quite sure.
So, are you
You know.
familiar with the work of First Stop Energies at all? The
Yeah,
work of
yeah. Oh, I had a good look at it before, and I made these instead of the POEs, simply because they'd obviously been around for a while. And there was
Well,
one
the
video
reason
that
why
I've
I'm
never been
asking
able
is,
to find again.
oh,
There's one video they
yeah,
did that I've not been able to find, and that was
they
they
got a
were
lot posted
All
putting,
of
on.
their
uh,
videos have been taken down. They're like impossible to
yeah,
get a
that's
hold of.
Mhm.
yeah. But there was a great one, and it was all to do with he was inputting that tonal frequency into it, and it was quadrupling in intensity
Mhm.
you depending on which, and I do have in the notebook. I actually took notes on it because I was interested because it was to do with acoustics basically rather than anything else, and it was very responsive to that as well. But I've got them somewhere. I haven't been able to find them recently though. But yeah,
The reason why I bring it up though is I wanted to ask you if you're using or if you've ever used or intended to use the Nunez method, the open circuit method that they employ in some of their designs. Or are you familiar with the open circuit method that they use?
no, no, I didn't.
Yeah,
I
I'll
I,
show it
I
to you
kind
real
of
quick. I
I
got a
looked at
diagram.
it. Okay, sure. Yeah, I mean, once I saw Gerald's coil, I thought that's the way to go.
Yeah, I appreciate that. I
Yeah.
want to teach everybody, so I'm glad you're interested. That's awesome. But
Oh, totally.
definitely,
Yeah. No,
you're
very
definitely
much so.
going to have to be in on that class that we teach. So it's
Oh,
been
I'll be there for sure. Yeah. Okay,
awesome.
so 18 kilohertz. See, okay, and what sort of results did they get with this?
So they claim that with this open circuit method, it maximizes the resonance within these vortex coils, and they're able to 10 times the voltage output while maintaining or slightly increasing the current. I've actually
Oh,
seen a
wow.
spike of energy at some of these higher frequencies. I can't actually use the higher frequency ranges with the setup I have. I'm kind of limited, but because I'm using a stereo amp receiver, basically to input the power and the tone. But
Right.
yeah, no, it's an interesting method, and not a lot of people are aware of it. So I tried to reverse engineer what they were doing because a lot of stuff got taken down, and I put a guide up, a do-it-yourself guide, if you're interested in the open circuit method and learning more about it.
Right. No, for sure. Yeah. No, it's interesting. Yeah, because I remembered Marco Rodin, as colorful a character as he is, he did that. He had what was that? What was that guy's name? Guy always wears the hat. Anyway, he basically did a reverse engineering project for Marco based on a
Oh,
video that they had, a live presentation of stuff. What was that?
Randy
You know
Powell.
the one?
He was the one who, yeah, he was the
Yeah,
one who
Randy
originally
Powell.
transcribed VBM on and put it, mapped it onto the Torrid for practical uses. And his work is actually what we're seeing a lot of in these coils, or remnants of his
Right,
work.
Yeah, Randy Powell
right.
followed Marco Rodin for quite a while after Marco Rodin kind of
Yeah.
fell away from
All
the
right.
line.
No, but this was a different video, and it was a presentation, like a live presentation with this guy who was in Germany or something, who had
Hmm.
wired the coil in a specific way and using a bass amplifier. And but he had, but I didn't really know enough about it to understand it properly at the time. But he was using uh, a bunch of high voltage capacitors, and he was creating what seemed to be more. a lot more coming out than was going in, to the point
Hmm.
where Marco Rodin actually asked, it's the guy who makes the model airplanes and stuff now. He has this kid called Charlie. I wish I could remember his name. Anyway, but he did a lot of work in reverse engineering that, but he could not find a way that it worked. And the thing, so that all kind of went away. But it was a similar, but it was more on this design of coil, that the continuous spiral, rather than the cross weave that the PoE coils are. But it's interesting. I mean, I've definitely,
So yeah, what I've seen with
I keep getting distracted down rabbit holes, and then I don't quite finish this one, and then I'll move on to this, or I don't experiment enough with this one, and then I think, ooh, that looks really interesting. I think I'll go there. But that's what I've done with your coil, Gerald. It's like I'm really fascinated by it because it's great. I mean, the fact that you've got that geometry and the rhythm all built into the coil is just awesome. Really good. Yeah.
Yeah. It
So
uses
First Stop Energy was actually using the coil that you use without the interference pattern, the design without the interference pattern, to drive rotaries more efficiently. And they were doing testing with that versus the interference pattern. They found that was the more efficient one to generate the magnetic field to drive the magnetic rotary. And I have videos on my channel of clips that I found on. You can actually go on their Instagram. The Instagram is the one thing that they have left. A lot of video clips of their experiments and stuff is still up there, where they're driving a bunch of different rotaries with different sizes of these coils, and it's really impressive.
All right. Do you mean I have to join Instagram?
Oh no. I honestly I feel you on that, but no, you don't have to join just to look at their videos. You can just go to
Okay.
First Stop
Okay. Good.
Energies Instagram, yeah, and you can see a lot
Oh,
of
right. Okay. So they're still around then. Well, that's good. Okay. Yeah. No, I will do for sure.
One Stop
Yeah.
Energies. That's the Nunez couple, correct?
the Nunez.
Yeah.
Yes, the
Yeah.
couple, we don't know what happened to them. They stopped communications late in 2022, early 2023. So they kind of dropped off of all their social media platforms went silent. So, but in terms of the information that's still left, their YouTube videos got pulled down. They had hundreds, but you can go to Instagram and find some of the remnants of that. And I did actually, in the do-it-yourself guide, I did manage to pull some of the screenshots of their website, which they had a forum link to in their website that the link was disconnected. But I found a connection to it while doing a Google search. Sometimes it brings up different pages from the website. And so I don't know how I found it, but I found it, and it had like a whole bunch of descriptions of all the videos that were taken down off of YouTube. So I managed to grab all that, and I have that documented as well.
Nice.
There you go.
Yeah, I heard whispers of they got snatched up by a private company, but again, just whispers. Take it with a big truck of salt. So who knows? Like you said, they just sort of.
I have no doubt that somebody, wanted to use them for some kind of project or another. So yeah, it could be.
I'm still trying to figure out how to get a rotor apart from a car alternator, because when I do, I've got a circuit that I believe once I put a bifilar coil inside that rotor, that the alternator will run itself. So it's just a thought. It's an experiment I've been waiting to do, but yeah. So
that's going to be a fun one. I can't wait for that one.
Yeah, that one will be interesting. Whether or not it does anything, we'll see, right? But we should all keep working on the stuff.
If the coil is putting out cold electricity too, and you hook it up to the car and it's going to the battery is going to be rejuvenated every time, it gets a pulse of that energy. So, so that's, wow.
Yeah.
That will be revolutionary right there if you can get that working.
Yeah.
Hey, Ian, you want to describe these coils here and what was going on?
Oh, these were the first ones I made for the Graviflyer, because I wanted to have tons of capacitance built into the coils naturally themselves. So I used I saw that Australian guy made a small one, and it's really low resonant frequency naturally, and I thought, I'll try and use these first, but boy, they are tough to make. So I made that jig, and you just basically the tape is its breakout voltage is 6 kilovolts for each layer of tape. So I put down 2 to get 12 kilovolt separation between the windings, and the rest of it's just bare copper tape. So, but you have to get it bifilar, you have to run 2 tapes at the same time, and then 4 rolls of the insulating tape, and it's difficult. It is difficult. That one was going well at that point. But I did manage to get them all done. But as soon as I put them into the Gravifly and I was impulsing, I was trying to keep the current as low as possible because I knew it was going to be a problem if I went over an amp. And I was only at about maybe 400 milliamps, and the heat had nowhere to go. And the coils were starting to buckle inside the formers that I'd encased them in, and it was just like, oh, okay, that didn't work. So that was a I should have known, but you got to try, right?
How else do you learn?
Fascinating. That's fascinating to see
Right.
the ingenuity to put that together.
That's awesome.
Well, you had to get the wrapping exactly to the millimeter right. You had to have exactly the right little guides there, so that it was lifted at the right point above the lower frame, and then the tape had to be a different height. And yeah, so anyway, yeah, I spent a few weeks doing that, and I was disappointed when I've still got the big one in the center, and it's still in good shape, kind of thing. But the others, yeah. But maybe if we end up going cold, then and there's no amperage going through it, then it may show some interesting properties at the end as well. Which is
I'll go ahead and pull up the other one as
But,
well.
How else do you know unless you try, right? I like.
Yeah.
I made 175 coils, but not all of them worked. So it just is what it is. That's experimentation. That's awesome.
Yeah.
Don't ever give up. Don't ever let anyone tell you it can't be done.
Yeah. Oh, that's one that I got. That's like 140 millimeters, so it's about 14 centimeters. In fact, it's a little bit more than that. That's as big as I could make the former on my printer. Let's put it that way.
Yeah.
But it's really tough though. You've got to end up turning it physically with your hand in the center rather than that center point, because the center point that the tool tends to break because there's so much torque on it now when it gets bigger, but also that it causes the internal rotation to contort, and it starts to display kind of weird behavior, and then it starts to bulge up in different places. Yeah, that's difficult.
That is
I
difficult.
won't be going. I won't be going there for any particular reason in the near future. Anyway. But it was fun. It was fun to do and to see it. But, yeah.
See, it's amazing what you learn from that too, right? That's
the
stuff that I've done.
There you go. There you go. That was perfect the night before, and I got up in the morning. I looked at it. I thought, "What the heck happened to that?" And it
just
was
too tight. It exploded on you.
Yeah. It didn't like what I did. That's for sure.
That's funny.
Yeah. Yeah.
That's absolutely amazing. That was so cool, man. I just love the ingenuity to go to one coil to the next to the next. You know what I mean? Try them out, see what they do, and keep building.
Yep.
Yeah.
The amount of Go ahead.
Yeah, because the Gravifly, I was hoping that I would be able to get enough electrostatic energy out of them, but I mean the inductance was way too high basically. But so then I was being able to feed off the same circuit, which was Evo's radiant power circuit. I reckoned that I should be able to take some of the stored energy that was going into the capacitor for recycling back into the system to go back through the MOSFET. I was feeding that off onto basically just like curved metal surfaces made of foil on the top and the bottom. So I was getting the positive on the top and the negative on the bottom, but I couldn't. That circuit didn't work. I got to go onto the flybacks to get that kind of energy that I need. It didn't. It was a couple of 100 volts was all I was getting of it.
From my experience, if you want to take your back energy and you want to put it back into the front part of the circuit, you have to have two separate circuits before you link it. It can't be from the same circuit. It'll never work. The resonance cuts out. I don't know why it's like that, but it just is.
Well, in this case, I was pulsing. I was a positive impulse going into the top with a DC offset, positive DC offset to get it raised up a bit higher. And then on the bottom, it was a negative impulse with a negative DC offset again for the same reason, to get as much pressure difference between the top and the bottom. But the problem is that the coils inductively interfered too much together. I couldn't, and it didn't really matter how far I separated the top and bottom ones, because I had movement there. And then also the magnetic field was too strong. Those neodymiums in those bowls at the top and bottom, they were oriented correctly, but they I was hoping that they would cause some kind of movement with the field around the coils, but then pancake coils are very good at holding the magnetic field very close.
They are.
So it's difficult there as well. So, but I thought that would work for electrostatic, but it didn't.
Well, like I was going to say before, it's all about the experiments it takes to get to where you're at.
Yeah.
I got like 12 binders of notes on all the experiments I've done. And I mean, fat, thick school binders, because it's not the experiment that worked. It's the 1,000 experiments that didn't work that brought me to the one that did. Right. So yeah, keep at it. That's your setup there.
What's going on here?
That was an earlier one. Okay, this was me just taking a dive into acoustic resonance and mixing it with electromagnetic resonance, right? So those, the center of the coils there, those are two solenoid coils. One is inside the other, and there's a primary. I had actually ended up with primaries on both sides, so I was just inducing, but that kind of didn't work. But basically, those are resonance speakers that are. I joined the coils onto them using little 3D printed cups and epoxy, so when the speakers would vibrate, they would physically put the vibration into the coils, and that's before I saw Nathan's low voltage method of actually putting those frequencies into the coil through that back door, as it were, kind of thing. So I was thinking, well, the only way I'm going to do this is to make coils that are going to vibrate physically, and also be able to adjust the frequency going into them. And that those coils, those are the ones that the complaints immediately started, because they vibrated, they resonated perfectly at about 7.5 kilohertz. And it's like, it was horrible to listen to. But
did you manage?
But I did. I tuned them so that I would then get a different octave or a different harmonic of that resonant acoustic frequency into the electromagnetic frequency, to see if I could get any anomalies coming out of the coil. I was looking for parametric excitation or something to see if the physical vibration of the acoustics would interact somehow with because historically this seems to have been a common theme in the distant past, where acoustics are used to do all manner of things. So I thought, well, I'd have a look at this and see if this did it, but it was complicated, because you're monitoring the resonant acoustic frequency using those little microphones that are hanging off the clips, and then electromagnetically impulsing the coils again with voltage impulses to get the resonance for the coil as well. Those are the tuning capacitor banks on the left hand side. That's the red container ships, as my wife calls them, and then
that's that Master Evo
DI box. Yeah, and then there's DI boxes to transfer the signal from the signal generator in through an amplifier, and then into the this, yeah, that's right, and then into the speakers. There was impedance issues. I had to use the DI boxes and stuff to be able to cope with that. And then I ended up after that, I found that the amplifier I was using, there was bleed through in the channel, so I couldn't separate it out properly. So I ended up getting a small mixing board and sending it through there first and then out into the amplifier afterwards. And that kind of cleaned it up a bit. But I couldn't get any anomalies out of it. Let's put it that way. It didn't kind of
Huh.
work as I intended it to do. But yeah, now that I'm not
That's-
limited with coils that are rigid enough to physically vibrate independently of each other, I'm really keen to get this circuit that Nathan showed, just using the little add-on board. Although it's only good to 20 kilohertz, but it's if you're working in acoustics and harmonics, and that should be good enough anyway for what we're trying to do. But it'd be nice to be able to do it with ultrasound as well, applying the ultrasound directly to the actual coils. So yeah.
That's different. I've never seen sound tried to be used that way. That's unique. I should try something like that. I've done it with a flame, but not like that. Like,
yeah,
interesting.
Well, that's as mandrolic as it gets. Really, it's just basically physically vibrating.
Yeah.
They're actually. But anyway.
But
again,
you never know.
We take a different design.
Well, I did a weird experiment one day that I don't know, I was just messing around. I wasn't thinking about it. I was pulsing the coil. I think it was like 528 hertz or somewhere around there. And I was collecting the back EMF in a LED bank. And then I took my lighter just to see if I heated up the inside of the inner core, if it was going to heat up the copper, what was going to happen. So I took my lighter and I turned it on and I just held it there for, I don't know, half a minute. And the voltage went up in my coil. And I thought that was kind of neat, but no big deal. And then I took the flame away and just forgot about the whole experiment. But it's thinking outside the box like you're doing that allowed me to understand that heat can actually be picked up in a system with a vortex. So maybe keep that in mind. And when you start doing experiments, try that yourself. Just a light flame.
Yeah, sure.
See if your voltage changes.
Right. Yeah.
So you want to take a look?
Oh
at
yeah,
this is the top and bottom part that you have on that solid state gravity flyer. So you want to explain it?
Primer field.
Yeah, yeah, that's right. It's the primer bowl or primer bowl, and his name escapes me. David Lapointe.
Yes.
David Lapointe was
Lapointe,
the guy who designed it.
Yeah.
Is it Point?
Lapointe, yeah.
Okay. Oh, okay. And so basically, the magnetic field that this produces is pretty unique, and it creates a rotation naturally, because when he was using the high voltage discharge from the center, it was actually doing a very, I'd say it was like 70,000 volts DC, positive and negative on the other side, and he was placing them upside down in a vacuum, and the plasma field that formed from the high voltage discharges was rotating in the center. It looked like a little galaxy, basically. It was incredible. So
Cool.
I figured that if you can get rotation out of it, and I thought, well, the reason for the copper mesh is probably completely misguided, but I saw that Gerard Morin video where he put the voltage across the magnets, and it played that tune, da, 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 that, remember? And I was thinking, well, if I pulse the same frequency of voltage that I'm resonating the coil beside it, and I just put a lower voltage pulse through the magnets across the surface. And there's a black insert bowl that would press all that flat hard against the actual magnets. I just took that just to remind myself which way that one went.
Yep.
So then I thought, well, maybe I can induce a rotation with the magnetic field from this and the coil, because they're all in the same sense in terms of the way the coil was wound and everything. I was just trying anything I could to try to get rid of the spinning discs rather than make the field spin rather than physically spin a plate, basically. So
Well,
yeah, that's where I was coming.
I know there's more than one way to skin a cat, but when it comes to the creating a vortex, and I know there's a lot of different ways of doing it, I'm not sure if you would accomplish it with this. That's a very interesting thought. I never even considered that. I know the primer field.
Well, I never.
Go ahead.
Mm-hmm. I actually never got to even try it because the coils distorted before I got to that point. And then I've had a couple of months of real silly busyness. So I've finally got back, and that's why I made the other coils now, which are more robust. But yeah, and looking at your coil though as well. I mean, that's really what we're looking for, isn't it?
Yeah.
It's certainly it goes a long way towards it, I think. So
yeah, Gerald's whole coil is beyond that gravity flyer. Let me tell you.
Yeah.
Sorry.
Well, thank you for that, Dave.
No. We're talking everything I need in all these mechanical parts are all in one coil. You know what I mean? We just throw the rest out. I don't need it. I need the coil. I need a piezo buzzer. You know what I mean? And that's about it. Because then you got the right frequency. You already have the coil. I don't have to mess with the Tesla coil. You know what I mean? And we have the high voltage in there because, hold on, I'll show you guys a picture in a minute. Gerald's coil is breaking out and it's got bubbles in it. So I want to make sure Gerald goes over that. And by the way, did you run the test when you see the bubbles?
You know what? I had to finish a contract this morning and I never got a chance to do that experiment. So that's on the list. As soon as I do, I'll send you that video.
Okay, I'm going to pull that up.
Okay. Yeah, I'm at the stage now where I understand the coil system to the point where I can hit it with one pulse and it creates spin. So the coil itself, you could, some people refer to it as a prime mover. I don't know about that so much. And again, it has to be tested extensively, but one pulse and it creates a spin kind of makes you lean towards that. I think that's the direction you should head. But again, I'm not.
Yeah, no, absolutely. I'm not attached to anything I've done. I just thought those were the ideas I had at the time, and whether it was correct or not it's always fun. It's fun doing it, and I love doing it. So it's kind of fun. But certainly the what was I going to say? Yeah, you were saying about the when I saw those little like shiny bubbles on the coil, I kind of thought, oh, I wonder if those are plasmoids. And then I wondered if you were conditioning the coil when you were running it. And again, it's like if the field is being moved and there is inertia in that field, then after it's off, who knows how long it stays around for. And I know that at the Cosmic Summit, when Bendel was showing his engine, and somebody had completely destroyed the bubbler unit the night before, so it was broken. But there was enough plasmoid coating or the energy inside the gubbins that takes it and separates the basically. There was enough in there. It was actually working fine without the bubbler, which is actually the implosion point. So it was working just on its own. He was relieved. I could tell. You can see it because somebody completely physically took apart the bubbler and broke the seals so that he lost the vacuum in it, and he didn't have anything to replace it with. But it still worked because it had been conditioned, because he'd been running the same generator in London, I think a couple of months before, showing it. So I'm wondering if you're saying that you can just hit one pulse and that's enough just to regenerate the whole movement that's conditioned in the coil now and around it. So I don't know exactly how that would work, but it's just a thought.
When we do the class and I explain it, it's going to be like this kind of a moment, and I'm not trying to degrade my work or anybody's work who is in this field, but it was like this for me. Oh, really? You know what I mean? So I believe that once you get that shown to you, it's going to be like that for you and everybody else. It was
Nice.
a lot simpler than I thought. You know, kind of like the KISS theory, keep it simple. There's another advocate to that, but I keep that out of the way. I don't like saying that last one. So, yeah.
Hey,
No,
Joe, do you
what-
want to explain
well, I'm
what's
looking
going
for-
on? Sorry.
Okay, so with the picture that you're seeing here, my coil was getting breakout when I was putting like, I don't know, I'd like to say 7 volts, but I'm not exactly sure because there was some tests around that time, so it might have been 12. But I was getting breakout on the bottom of the coil. And so I figured I'd put it in resin. So I put it in resin. I didn't vac pack it, but I did the resin in such a way that I put it on a shaker and it shaked all the bubbles out of it. It was like completely clean. I showed it to Jeremiah Pop and he even commented thinking, he said that it was amazingly clear for, you know, my first time at doing epoxy. So I left it at that and I started experimenting with the coil and doing videos. And just last week when I was on live with Nathan and Ben, I looked at it at the light and it was like I seen 1,000 points of light coming through it that were not there before. And it kind of blew my mind. So the next day I pulled up my, I have a digital microscope. It's 1,000 times magnification. And I looked at the epoxy where those points of light were. And this is what I saw. Multiple perfect bubbles. Now, at first I thought it was just bubbles in the epoxy. But once you look at where those bubbles are and where they're coming from, it almost looks like they're coming out of the copper. And that the epoxy is holding them in stasis because they're slowly coming out through the energy push. I could be wrong. It's a theory at this point, but I'm going to keep running the experiments and I'm going to do the next one to Nathan's suggestion is put the microscope on while I'm running the coil to see if there's any change. So what you're seeing here could be EVOs or it could be just bubbles inside the epoxy. But the experience states that they're not just epoxy bubbles. That's where it's at. But I've never seen a perfect epoxy bubble such as some of the ones that are on this video. And if you look to see, go ahead.
Somebody else pointed out that they're all on the wires. And no, if it's air bubbles in epoxy, they would be randomly wherever they were or rose to. They shouldn't be on the wires only, right?
Yeah, and if you look at some of them, it almost looks like they're pushing outside of the wires, like they're coming out of the wires themselves. So interesting nonetheless. It's going to require testing. And if the bubbles don't come out of the epoxy themselves, I might consider cutting this in half and sending half of it to Bob Grenier for SEM testing. But we'll see.
Yeah.
So that was the latest video. They could be EVOs that are held in stasis in the epoxy, or they could be air bubbles, but I'm leaning towards them not being air bubbles. But again, that would require some testing.
Well, I hope you do your presentation on Friday, this Friday. I hope
Yeah.
you do.
I hope I'm ready for it.
You better be ready, Gerald. You had 2.5 months now, buddy.
Well, you know what, though? I had a breakthrough right after APEC because I was so like I've been waiting for this, and then this stuff occurred. So I went and did some experiments, and I had another breakthrough, and I had to add it to the paper. So I got to go over it, and hopefully I've got it right. I'm shooting for this Friday.
Yeah, everybody
Nice.
wants to see it, man. Everybody's on there. We're all looking for this thing, man. It's just going to change everything. It's a total game changer what's going to happen here. So don't keep us waiting anymore. Find a way. Call in sick. Do what you got to do.
It's
We
not
wanna
my
hear it.
fault. It's not my fault that it didn't come out the way it was supposed to. It should have been on APEC. It should have had a whole bunch of people looking at it other than just us. And you know what? Piss on it. I feel honored that you are allowing me to do it on your channel. So, yeah, they lost out. That's the way I see it, you know? I'm going to share it with the world. That's it.
Well, if we do it here, man, you got the whole thing to yourself, and we'll just pop in and watch and kind of comment a little bit. You know what I mean? That's
I
it.
hear you.
You know what I mean? So it's all yours, man, because we've been waiting. I'm sure you'll get a billion questions. I'll do my best to stay out of it and simply just ask the question when needed.
Well, you could be the narrator and ask the questions that are in the comment section. So there you go. That's awesome. Yeah, and I'm going to try and replicate one of my craziest experiments. I won't fully give it up until the day of the presentation because I don't know if it's going to work again, but I want to redo it. And if it works behind the scenes, I'll do it on camera so you get to see some craziness.
Nice.
Yeah.
Yeah, we've all been
all right.
looking forward to it. I ran
Friday
a
sounds
video-
good.
Yeah, I ran a video
I'm
today
shooting.
of your stuff, Gerald, by the way. So
Sorry?
everybody, I ran a video this morning of all your stuff. You know what I mean?
Yeah, I caught a clip of that. I hadn't had a chance to watch it because I've kind of seen it before, but your comments always keep me thinking. I like that, right? So I always end up watching what you put out. Yeah.
Well, I just want to make sure everybody's aware of it, man. We're building up again to this whole presentation. Don't let my bubble pop again. Okay?
No,
Don't
we're
let
doing
that
it.
happen.
We're doing it, and that's it. You know, and
Nice.
either people like it or they don't. Take it for what it is. Take it and off. I don't care. I'm just out there to show what I believe is truth, and I hope. And I said this to Nathan, Ian. You look like somebody who has to be on the list. So I have 43 coils made now, not 39 anymore. And they're going out to a group of selected individuals that want to test this tech, pull it apart, debunk it. In fact, that's what I told Nathan. I want you to debunk it. I want you to prove me wrong, because if you can't, that means I'm right. And if you can, maybe I'm missing something. Maybe I'm looking in the wrong direction. I want that information. So my intention is to send out as many as I can make. And they're coming with a book. And the book shows you how I got there, the dream, the platonic solids it's based on, all the 7 instabilities that allows energy to flow through the system, like diclotron instability, the skin effect, parasitic capacitance, kinetic inductance, the Miller effect. There's the proximity effect. It all comes into play. It's not one thing. It's all these things, or it wouldn't work. The system's dynamic. So when the time comes, I'd love to send you one. Doesn't matter where you are, Europe,
Fantastic.
wherever, I don't care. I'll send it to you and pull it apart. Oh, and I am sending as well number sequencing for you to build your own. So from that point on, once you get the coil in the book, you'll be able to build your own. You'll be able to look at the experiments that I've done and replicate them, or not, whatever you decide. And you'll be able to take the number sequencing and start building your own geometrical forms of coils. And I think I included about 18 different types in the book itself, and then just going to let everybody take it from there. Sure, I built all the other ones, but big deal. I'd like other people to build them without me influencing it and see where people get, because who knows what's going to come out of it, right? So that being said, on the list.
I love that. Fantastic.
You're on the list.
Right.
Yeah.
Thanks.
Sure. And I appreciate everything you've done, Nathan, putting me on and, showing my stuff. I appreciate that. You're muted.
You're muted, Nathan.
Yeah,
Very-
I got out of the conversation because I wanted you guys to talk. Because
Okay.
I had talked with Ian before, but you didn't get to talk to him yet. And everything you guys are doing is kind of like, you know what I mean? Going back and forth with each other. It's just amazing.
Are you in, if you don't mind me asking, Ian, are you in Britain or Australia or where are you?
Oh no, I'm in Florida.
Oh, you're in Florida. Even better. That's even better.
It's easy.
Easier to send you
Yeah.
stuff. There you go. You
Oh,
have an
yeah,
accent. That's
absolutely.
why I asked, right?
Sure.
I'm
I'll cover
Canadian.
the cost of postage. I'm easy.
Oh yeah, I'm not even worried about that. I'm not worried about. To me, it's like everything that I've done, I've paid for, or I've gotten out of recycled parts or the garbage and turned it into what it is. So as far as I'm concerned, if I have to put up the cost for shipping to every individual, I don't care. It's not about that for me. I don't care about the money. I don't care about the fame. I want to get this tech out. So to me, it's just part and parcel of it, right? But I appreciate it.
Absolutely.
Here you go, Ian.
No,
this
it's
is
just
his
help
little thing of coils. He's got
Yeah,
going on.
I saw this. Was it yesterday you put this out? I think.
Yeah, I put it out.
Oh
Yesterday.
yeah. I saw this. Yeah. Those the two in the top left, those did not work, right?
No, not at all. They were actually mimicked after a brain sequence that I was studying because I was studying the brain for a while. And no, they didn't work. But I put them out just to show, not everything that we do works, but who cares? It still brings you to an understanding that you can jump off of, right?
Yeah, absolutely.
It's all about learning.
All right, Ian, I'm going to open this up to
Nice.
everybody. Is there anything you wanted to say real quick before I let everybody else in?
No, I'm good. I'm good. Thanks. Yeah, appreciate the chance to have a chat.
And
Great.
I appreciate you following my work, and I appreciate you being willing to debunk me later. So thank you.
Mike, what happened? They're like half there.
You look like you're in a portrait, Mike.
Your mic's not on, Mike. Hey, look at these smiling with black teeth.
Yeah. Looks like he's on Pirates of the Caribbean. There you go.
Mike?
Can hear you now, Mike.
I'm I'm in Deep Space Nine. Deep Space Nine, man.
Yeah, almost.
That's so great. It looks so funny, dude. I'm sorry. Awesome.
Yeah,
Totally
you
awesome.
should have faded into the camera slowly, Mike. Done it all Darth Vader like. That would have been cool.
Oh my god, that's so great.
Nice.
I got a green
Alright.
screen, things you can do with a green blanket.
I hear you. I got one of these white for the projector that's above my head. I'm trying to get it set up for when we do live. It's going to post stuff behind me. We'll see how well it picks up on the camera, though.
You gotta do it on the projector, not like pull it off on the screen. And
Yeah, well, no, I got like different types of media, and I got a digital projector that's bolted to the ceiling above my head. I just have to adjust it right, and then it'll show up here while I'm talking to you. But I mean, that's not my only way of doing my presentation. That's just an added bonus.
oh, right on.
It's like this
Cool, man.
whiteboard, right? It's old school, but it's an added piece of media that you can use to show what you're doing.
So you're gonna do an experiment on that day, or are you gonna show like a live experiment as well?
That's the intention.
That's
And it's
cool.
going to be something that isn't on my channel. It's going to be something you guys haven't seen before. If I can replicate it It's in my book. I've done it before. But again, we'll see. I'm not going to even bullshit myself here, right? This one's a little bit crazy. So that's why I said we'll see some craziness if I can get it to work.
Cool.
Sean wants to know what's in, what's out.
Depends on what it is that I'm doing with the coil, but my watts in on lighting that one cube in the one video we shown was 1.8 watts, and watts out. You know what? I didn't hook it up to a meter at that point, but the light itself almost blinded me. So it was at max, and it takes 94 volts, 1 amp just to light one panel, and there's 4 panels on that cube. So I will do the watts in, watts out and put it on video in the future. I just have to get a second meter.
I remember the Whoppers. Too bright. Got to have some Whopper box in the middle.
Yeah, I had to go Whopper time on that one.
You know, what I see with these coils potentially doing is reusing the flyback right away.
Mm-hmm. Yeah.
Based on the way they're wrapped so close together. In a way that the flyback doesn't get a chance to, well, I mean, it can radiate onto the other coil as well, you know, any other coils close to it, you know. So when you have so many coils that are not doing anything, but one of them is being energized and the rest are just sitting there doing nothing, they're basically stator coils, you know?
Kind of.
And that way you can use them in the way they're wrapped around your primary. If the primary is the one you're pulsing, I don't know if that's what you're calling it, right?
Yeah.
It is, okay. So yeah, the primary coil, if you know, is being pulsed, these coils wrapped around there are statoring that primary coil, and we don't really do it like that. Nobody's ever really done it like that. You know, it's just a transformer, primary, secondary, one coil and another coil, but not a third and a fourth and a fifth coil, which is just a third and a fourth and a fifth layer of picking up EMF fields that would otherwise be wasted.
There's 12, and when I put the whole system together, there's 15. And they all pick up individual.
You got forward EMF, and you got backward EMF.
Yep.
On the flyback side.
And I pick up on 12 on the outside, and I can pick up 3-phase on the inside of the core. While I do think the
flyback side is a little bit weaker.
Good eye. It is not by much though. It's about.
But I have a theory how to overcome that. If you want to hear it.
What's that?
I have a theory how to overcome that if you want to hear it.
Sure, go for it. I'm always open-eared.
Okay, first of all, you got to get your forward signal in phase with the flyback signal. And
I can't because the system.
One of two ways you could do this.
Okay.
Hold up, hear me out.
Okay, sorry.
You can delay. You can't really delay the flyback signal. So that knocks out one of the two ways. I thought you could. You could delay the flyback signal with a capacitor, recreate the same signal by delaying it, but you can't recreate a flyback signal with a capacitor. So you have to speed up the flyback signal. You have to speed up your forward pulse to catch up to the reverse speed. Mm-hmm. So if you're going on, and I didn't say off here, I just said on. If you're going on at a certain rate, remember the rate at which the flyback goes in reverse is quicker than the rate at which you go on. So if you can speed up your frequency of your on frequency fast enough, you catch up to the rate of return of the flyback's speed of frequency, which is at an unknown frequency. It's not at your frequency, whatever frequency you're pulsing on and off at. It's not at that frequency. I'm talking about the frequency of which it returns. The speed of which it returns is is a frequency in its own regard.
I get exactly what you're saying.
It's at light speed, technically speaking. It's light speed.
I will try your
How do you
experiment.
catch up to that frequency? So that's the theory. If you do catch up to light speed, yes, you can put your forward pulse in phase with the reverse flyback and create a amplification.
Yep.
Done. Because you're in phase and the two signals are in phase. And if your primary signal is at the speed of the reverse signal, which is hard to achieve considering it's light speed.
Mhm.
You know, what I'm saying is the rate of which you go on and on is at that speed, light speed.
Yep.
Then you are at the rate of the return path of the flyback. You're at the same speed, which is in phase.
Well,
And so your signals will overlap. The two flyback signals will line up. And if
Okay.
your primary signal has a gain of 1 or more, doesn't matter what the secondary signal is, you're going to have amplification.
So
As
I
long as
see.
they're in phase, as long as
Hold
they're
on,
in
hold on.
phase.
You're gonna pull off the Hutchinson effect if you start crossing the beams here, okay? You know what I mean? You're not. Yeah, unless you want to fry something, I wouldn't try it because you need
No,
a north and a
it's an
south.
experiment
and
that's
you
probably
need
not
flow.
even possible.
Yeah, listen, you need flow. If you take off the flow and keep it concentrated, get ready to blow up whatever's in the center.
it heats up the coil itself, and then it'll blow the transistor. I understand what he's saying, though. There's
So we have
another.
transistors that can switch at light speed. It's not going to happen.
So there's
You're not going
another
to be in
way.
phase. You're not going to be in phase with your primary signal, or the reverse signal resulting from your primary signal. Is what I meant to say.
There's another way of pulsing it that could allow Mike's experiment to work. And you know what? I'll get into that. Maybe not right now because it's going to take a little while to explain. But there is a way. Remember, there's 4 lines on this coil, right? There's a positive and negative on the primary and a positive and negative on the secondary. But you don't have to pulse from your primary's input or your secondary's input. What if you pulsed the primary's output and the primary's or the secondary's output? This system, because the way it's geometrically formed, does totally different things depending on how you pulse it. So I understand what you're saying, Mike. Let me give you something to think about. What if there was a way of pulsing the primary and allowing the secondary to pause the energy that it's collecting and releasing it just before the pulse of that primary
To put them in
they
phase.
come in balance to perfection? Let's just say this system can do that. But it matters on how you pulse it and what you're putting on your secondary to allow that energy to flow so that it can do that. Does that make sense?
So are you winding it like a bifilar coil then? Positive and the negative, or you know what I'm saying? And
Yeah,
it automatically pulses back?
Yep. It acts as a wave. So when you pulse the primary, right, through induction, the secondary picks it up. But when that power is released in that secondary through either the capacitor or the diode or even pulsing itself, it takes that wave that it accepted and spits it out the exact same way, 180 degrees out of phase, at such an extreme rate, it's almost as if there's no delay whatsoever.
Right. According to the Nunez method, it doesn't matter where you start as long as you create that toroidal field, the counter rotation, and that's what matters.
So isn't the flyback 180 degrees out of phase with the forward voltage?
Yep, it's wired that way.
I mean, it's just the natural effect of it.
Yep. The minute I tap the coil once, it's 180 degrees out of phase.
No, what I'm saying, isn't the flyback 180 degrees out of phase with the forward?
With the primary, yeah.
No, the forward voltage, your plus to minus signal.
Yeah.
Then you turn that off, and now it reverses polarity and goes the other way. Isn't that reverse polarity flyback 180 degrees out of phase with your forward?
Yes, it is. Yes, it is. But remember, my flyback doesn't come off the primary. It doesn't feed back in the primary. It literally is captured by the secondary. So
Right.
as yeah,
Do you attribute that to the bifilar winding?
yes, but
So, and
but
do you
it's not
attribute that
just
to being
bifilar.
180 degrees wound, 180 degrees out
It's
of phase?
bifilar 180
Mhm.
degrees out of phase wound that makes the system work. Well,
Right.
it's
So being a
part of
bifilar
what
and being
makes the
180 degrees wound, 180 degrees out of phase with the primary wind also helps the 180 degrees flyback signal to better be received.
Yep,
see what
I
you're saying.
capture it almost immediately. I would say instantaneously, but my eyes can't pick up on that. No
That
human
makes
eye
sense.
can.
That makes sense why I get self oscillation effects sometimes on these Bedini SG systems. They're bifilers, you know.
Oh yeah, Bandini, he knew what he was doing. Like the tape deck video.
At first, I thought it was a battery.
Did you watch it?
Did I ever? Not only that, I was looking at the circuits and I was looking at what he did. I think I figured out how to run a scooter motor all on its own.
Oh, that'd be cool.
Not sure yet. Big boast. But what Bedini did, man, with the SSG, guy was a genius. And all you have to do is apply it to the windings of a scooter motor, and on your resistor for your Jewel Thief circuit, you use a throttle, but you have to have your resistance matched to the right system. So
I see a lot of these circuits, even the ZVS. It looks like they're using the flyback to trigger the ZVS, and it even looks like that with the Bedini circuit. Like it's in a lot of these oscillators and the Jewel Thief, they're all using the flyback to sustain the triggering. You
Yep.
know?
And I could.
It seems to be looking like that the way it's wired, you know. And stuff.
But that's not my goal, though. Right? Could I run it into a loop? Sure, I could. And then I get kicked off YouTube. They won't allow it. Any video that you close loop your system on, you're getting taken off. So
Really? I thought
yes, you've never seen me do it, and I don't think I ever will, not unless I'm ready to go bye YouTube. Because I mean, I don't know, right? I don't want.
I was considering just running a live stream with some of my pre-recorded videos, you know, just on a server, because I see a couple of other main like channels do that. Like I think the Young Turks just has one just streaming 24/7. So if they can do it, you know, like I don't know, like maybe I can set up a server somehow and just run one, so I can have a continuous stream like 24/7.
Maybe, and then just let everything out on that. Never let it shut off, so they can't algorithm it.
Your ISP's gonna knock on.
Yeah, because it's when it closes down is when you get flagged, isn't it?
Yeah. Just leave it running.
No, your
forever.
ISP is gonna call you. Hey man, we need you're hogging all the bandwidth.
Give me 1 second, okay? 1 second. Listen,
You
I'm
need
gonna
to
post
upgrade,
in
man.
the. I'm gonna
Upgrade your
post.
plan. Get the.
I'm gonna post in the chat right now, okay? Where you can find the link to the tape motor. You're also gonna find, what was the other one I showed you, Gerald? The one from Germany.
It's on the tip of my tongue. I just can't remember it at the moment.
Anyway, I'm gonna leave
Howard Johnson. Howard.
No, it's not that one.
Okay.
It just has one name. Just one word. Anyway, I'm gonna link it in the description for you guys. Enjoy it. Go on there. There's 26 videos on there for Bedini. It's also a research place, so you can go on there and find stuff on Hutchison and some other people. You can also pull up articles and stuff. So here it is, guys. I'll send it.
Great. Thanks.
Yeah, I tried to find my email link because I signed up for Hutchison's his membership package, you know, the $34.99 or whatever, to get access to all of his videos and information on there. And mysteriously, the email, like not the receipt email, but the email with the link in it is not in my inbox anymore. So I looked all through that son of a bee, and I don't know what's going on, because I know I looked on stream for at least 2 or 3 hours looking for that thing in the inbox, and it was not there.
Did
I'm
you
like,
look in
what
your trash folder?
No, that's actually something let me look in the trash folder
Just
right
in
now.
case it got put in there on accident, you know what I mean? Just find out.
No, that's a good idea, because you know, I don't want to jump to conclusions, you know, like I don't want to say like, oh, somebody like did this maliciously, but I did have a link in there with access to his membership, and I wanted to live stream some of it, but I'll check the trash right now.
You do know that you're on live with one of the most like shadow banned people on the internet, right? Just making you aware.
Yeah. I mean,
Yeah.
you've seen some of the content I put out, and what, I'm not even at 1,000 yet. Like it seems like my channel's like plateaued.
You know what? Your channel grew faster than mine. I'm just
It did.
Yesterday, the day before, I was at 705, and that's taken me a year and a half to build. And I've been on lives endlessly, and you know, in the background of APEC, and dealing with like Jeremiah Pop and Jeremy Reese and Alien Science, all that, right? And yeah,
people want
And something that really helps is reminding everybody to let's subscribe to Gerald's channel right now. Everybody watching, we got 36 people watching. Anybody that's not subscribed to Gerald's channel, he's got a really great set of videos that
appreciate that.
I really enjoy. Yeah.
What were you saying, Mike?
People want to see them circuits, man. I mean,
Yeah.
most of your viewers are going to be, you know, technically savvy, and those are the guys that are going to want to see the circuits, guys and girls, whatever.
I'll do a schematic for what I got.
Look through the
I mean, I know you don't want to
and
know,
see
you
where
don't want
get
to
your
show it,
spikes,
but,
you know.
No, it's not that I don't want to, Mike. I have no problem drawing a schematic. It's just how do I put this? I suck at it.
maybe just one for not to be accurate or nothing, but just like to give a basic understanding of what's the fundamental principle of what you're doing, you know?
Okay, I can do
Yeah,
that.
people also like to see you in front of camera, you know, like maybe with a diagram pointing
Don't have to
and
be, you know,
describing the
detailed
science.
and all that, but just
Maybe
enough details to see what the concept is, you know? I mean,
Yeah,
that's how I
people-
make my stuff.
yeah,
There's not a
visual
lot of
learning.
details in my stuff, but it shows the basic concept, you know?
I get that.
It's a Lockridge
Yeah.
device.
Well, let me just.
Video demonstrations are great, but you can't tell how everything's connected like that, you know?
Hold on real quick. Lockridge device. They
Yep.
pulled out of Germany after World War II. It was an over unity device they used to light up all the tunnels under the ground in Germany. So
Right.
Wow.
they brought it back to the U.S., and the guy that was researching it wasn't able to put it back together. So he gave it to Bedini, or his family did. And I can't say what happened to him. Anyway, it just didn't work out. And Bedini said he would never release it until he got it working. So it never came out anywhere. He just shows you a walkthrough of what was in it.
What is it called? Do you know?
The Lockridge device.
Yeah, you got it in chat right there. Lockridge device. Interesting.
I believe that was the one that was 400 watts all day long, right? Like
Yeah,
it wasn't a lot of power, but it was
Wow.
enough power that if you had 2 or 3 of them, you'd be running your house or something to that effect.
And what was it? No input power or low input power?
I think it was very low, if not none at all.
Hmm.
Yeah.
I
I
mean,
can't
Joe, if I
remember.
had
It's
a
been a
diagram
while.
of your stuff, I would have built it already.
It was over Unity. It looped. So
Yeah,
as soon as they got it running, it stayed going. And they actually had a version of it that went in campers inside the U.S. And they would only sell it to people who had campers. So, but
Oh.
they would go to replace the brushes, and they replace them with the wrong ones, and it would
With the
ruin it.
rock
It would never run again.
Yeah, anything that's over 200 or 200% over Unity is going to be able to run itself indefinitely, you know, as long as the parts hold up.
Well, the alternator generators that I built, I get 400 watts out of each alternator without any input whatsoever.
Gerald, you should have one of your coils that gets 200% or more efficiency, and just see if you can just
splitter
run it,
alternator?
in like a time lapse.
What do you mean? Like just to run it continuously?
Yeah.
I know what it'll do. It's one of the reasons why I don't do
Oh,
it.
will it build up? Will it just build up, and then just because you don't have any load on it or enough load? Yeah. No,
Create
it'd be
enough-
cool
enough
though if
this-
you could just show it just running indefinitely. But yeah, like you said.
You know what?
Internet Archive, just so you guys know, it links right to this. You see them all down in here, all the links. You can download them on the bottom right-hand side. You'll be able to get to them, link it, pull it down, do what you guys want, watch them, load them up, keep them on your own server, have fun with it.
Oh, nice.
Awesome.
Thank you, Nathan.
You
Oh,
guys
great.
want to see a
Thanks.
Bedini mod pulse motor?
A which?
Do you guys want to see a Bedini modification pulse motor? It's like
Sure.
it's based off the Bedini SG setup, but it's like a modified version.
Sure.
Sure.
I'll show my circuit later on. It's a modified Joule Thief. It's really, there's not much difference other than a small capacitor bank at the right spot and then where the ground goes, which is actually one of the key factors to raising it a second level. But we'll get into that.
It's a magnetic relay, and it's moved up and down with two little electromagnets. So there's a magnet. You move a magnet with two bars attached to the magnet, and you move that magnet with two electromagnets, and you'll see that. And then it triggers two power sources to two coils in sequence, sequentially.
Nice.
I call it a double source, double pole throw relay, which I don't think they make that. You have to make a commutator to do such a function.
Are you thinking about actually building it?
Oh, I kind of already did in the schematic here. It's definitely going to work based on the schematic. And
Oh no, I'm just excited to see.
I'm going to
an
build it.
actual-
Yeah, I'm going to build this relay. I have to because I
How
don't
long
want
do
to
you
use
think
a
it'll take you?
commutator. Oh, I'm going to get the printer, the 3D printer. Nathan.
Oh, okay, yeah.
I'm
It's
working
gonna
on
take
that
me a
myself.
couple months to get phase 2, and
Yeah,
I'm going to have to learn the damn software now, which is what I don't want to waste time doing. But
Dude, it's easier than you think. It'll be like 2 seconds to learn.
I hope so.
yeah, 3D printer will make everything easier. I'm planning on getting one at some point.
Creality.
I got 6 sitting right beside me. I got another 4 over here. Trust me, I just sold like 5 or 6 of them so I can do more experiments. So, it's
Why
a
did you
fun
need
thing.
so
Like,
many? You kept upgrading or something?
they're for different things. One's for ABS only. It's enclosed. Another one was dual head, so it print one color then another color.
Wow.
I had 400 by 400 beds on them. There are 2 of those. And then I sold another one that was a faster version of that. And then these are just slower versions, but I put them on fast speed. So they absolutely keep moving. So like a 14-hour print, man, we're talking 8 hours. I can knock down things in half. Trust me, I change the nozzles on them and get them with bigger, thicker stuff so they fly out faster. I hate waiting. I want a prototype, get it done, work on it, you know what I mean? Blow it up, build another one. So it's got to go fast.
Yeah.
Does the temperature of the material help if it's like not heating it up too much and not as viscous or too viscous?
Well, it depends what you're working with. Normally, you're just working with, PLA. If I run ABS, I'll just take one of these areas over here that I have, and I'll just put the front on it, and it'll seal up the whole thing. So no air will get to it, because with ABS, just walking by it makes it lift. So it's a pain. You have to keep it enclosed.
The things that I could do with a printer. I have
Yeah.
designs of things I haven't even shared.
You know, I keep saying this: buy a CR10 used, get it for $80 to $100. Okay, it's not bad, and just get on the thing one-on-one with me, and I'll teach you how to build it, and we'll get it going fast because it's a 300 by 300 bed, but I can cut the time in half. And all the new printers, they can't go any faster than that CR10 can right now, unless you're talking about Bamboo Labs or you know what I mean, something like that.
Yeah.
But
Really?
Well,
yeah,
when I'm in the market for a 3D
They
printer,
got
I'm definitely
CR10s
gonna
for
consult
under
you.
$100, huh?
just go on OfferUp.
Huh.
Okay.
OfferUp or something like
Let's
that.
check it
That's where
out.
I go. Local people, they all just want to get rid of the stuff. I find them for $40 sometimes, and all they did is somebody ripped off the head and they didn't know how to put it back on. You know what I mean?
Huh.
They did-
Yeah, I'm good with that stuff.
I just, don't feel wrong.
How much are they? Are there heads? You got to buy new heads or something, or
They all have it there. They just have no clue about the 4 or 5 bolts that goes in it. That's
Oh.
it.
Makes sense.
I get people like that all the time. They burn a wire and they think they burned everything. And it's like,
Right.
Yeah.
it's just a wire. You know what I mean?
I've got an OnQ amp that's 250 watts a side, and the person gave it to me, and I was like, I'll fix it and give it back to you. And they're like, nope, it's garbage. I don't want it. It pissed me off. I was having a party. I took it home. I changed the fuse. I have a brand new amp.
Oh, by the way, Ben, how did your amp come out? Did it live?
No, it's dead.
Oh.
oh
died.
man,
I haven't
Yeah.
taken it apart yet, though. I mean, I could rejuvenate it. I could bring it back to life.
did
but
you
I don't
open
know.
it
I
up?
haven't
Did you
taken it
take the
apart
cover off and look inside there?
yet. Not yet. Not
Oh,
yet.
well, yeah. Come
Oh,
on,
then
now.
you don't give up yet, man. You didn't even open the box, man. Come on.
Hey, Ian, he was
Could be
running
just a
his.
fuse or
Hold
It
on,
flashed.
guys. Hold on.
It flashed like a resistor burned.
fuses do that.
I mean,
fuses
maybe
do
or
that too.
fuse. Yeah.
Hey, Ian,
So
didn't know.
that's-
Tell him what you did. Tell him what you
Resistors
did with the
don't
little
flash.
ball in your thing.
I mean, sorry, transistors.
I was doing here. You want me to present
Fuses
so you
flash
can visually see what's going on?
or transformers.
yeah, if you have it real quick, that'd be cool.
It's your transformer
Yeah.
or the fuse.
Or he blew a cap.
You would smell that. It would smell weird, or you hear a bang.
That's true. That's
Oh,
true.
dude, no.
Or you hear
He
or
blew probably a
you know,
resistor.
Yeah.
you'd hear air popping or like.
Yeah,
steaming out.
resistors get red. They get pretty bright.
Yeah.
But the resistors smell like burning material. You smell it clearly. And
Wait,
the
said he saw a big flash.
Transistors, they don't. You can't tell if a transistor is bad. without
He's seen the
putting
puff of smoke too. I remember when it happened.
Yeah, that could be the transformer. That sounds like the transformer.
Yeah, maybe.
It's a $5 transformer. You could probably replace it. You know, got to do.
Well, if
solder
you ever
work.
get up here, Ben, I got an extra amp for you.
Probably even rewind the burnt winding in the transformer if it's burnt.
So this is me pulsing at the Schumann resonance. 8 point. What was it? What's that? 8.
With all the
or
complicated
7.83
physics
or
Seven-
something like that.
7.8
engineering involved in
7.83.
these systems.
Yeah.
Yeah.
Here's the kicker. It wasn't that
So this is basically here. I'll show you the circuit.
use of a Ford diode and single capacitor. The Nunez called this design the PoE Vortex Coil. It stands for Peace on Earth, but I just call it the Nunez design to give them credit. After all, they were the ones who came up with this easily made sliding disc frame for our coils. They not only made it, they perfected it. And we need help trying to recreate their advanced version 3 432 vortex
So as you can
coil.
see,
Jordan from Alchemical Science might be
I'm
able
getting
to tackle this
over
one.
unity in
The
this.
frame needs to have a very thin V-shaped opening for a single wire set.
So this is the advanced version 432 coil that supposedly won't produce any ozone like some of the other coils that we see when pulsed at high
That was
or
cool.
High
yeah,
frequency. Yeah.
right.
And you have that one now, Ben?
No,
Is that
this
your
is the one
winder?
I'm trying to. This is the one I'm trying to get people together to try to recreate. So I don't have a 3D printer to actually recreate this, but it just needs to have the opening needs to be very thin, so one set of wires can set on top of each other very delicately and evenly, very thin V shape. And supposedly this is their most advanced design for over Unity production, and also healing, they claim, at least.
Okay.
PEMF. I got papers on it. It's the real thing, man.
But yeah, this is the PoE vortex coil. As you can see, it's not perfectly symmetrical, but it still works. Yeah, I didn't think I'd be able to get it to work, honestly, but it works.
Nice.
Nice.
Mm-hmm.
Very good.
The geometry is the determining factor for the presence of a detectable magnetic field. The closer you get to this precise geometry, the more you are choosing the path of least
It's a
resistance for
nice,
the energy.
even,
In a straight line
360
wire,
degree
you couldn't be further
turn
from this path, since nothing in the universe
in
travels
electrons
in a straight line. Thus,
motion.
it is within the realms of conventional science to assume that geometry is an integral factor to maximizing the performance of any system. This is not just one system. It is an all-in-one system, a transformer, a resonant circuit, a Tesla coil, a strong electromagnet. It is the holy grail of physics, a system unaffected by the weight that it carries.
So this is the two circuits that I managed to grab from their website. As you can see on the left, there's the traditional closed circuit that produces a speaker, or it's good for, a motor, propelling a rotary, I assume. And on the right, we have the open resonant circuit, where you basically have a crisscrossing of the input and output for the two channels.
Yep.
And this, supposedly maximizes the resonance, allows it to resonate more, or gives it more of a cavity to resonate. I'm not really sure the exact mechanism,
Sorry, go ahead.
Go ahead, Gerald. No,
Well,
go ahead.
See, that's the same thing as a PMH. What it does is it basically crosses your field, so your voltage is going down one way, and then as you push voltage the other way, it's like creating current. Does that make sense? I'm not explaining that correctly, I believe. but the PMH itself is wound the same way. It's the end of one coil goes into the beginning of the other coil, and because of the way that it pulses and the fields run, it actually creates current.
Right. You see on the left here, they say no vibration. There's a vibration spin for the magnetic dipole or whatever, and then there's no vibration spin on the open circuit. So what I detected was no pole when you put like your physical magnet detector in there, the one that's on the hinge, just a magnet on a hinge. It's clearly got an electromagnetic field, but then you put your digital detector in there, it doesn't detect anything. Well, it's probably got something that's very, very sensitive, but it's condensing it, I think, down to nothing. And you can see in this video, where is it? The magnetic monopole test that I did.
When the field disappears, I call that the null zone. That's right in the center of my open core, like right in the very middle. There is no field. It just nothingness. And
Right.
I think that's what the rodent coil does.
The rodent
in this
coil is
video,
also
there's a
bifilar, right?
Up the gain a little bit. Yes, the coil is bifilar. So just real quick, because I don't think Ian is aware of how many wires I have in there. There's 24 wires in there, and they're separated into two channels. So they're all in one bundle, twisted bifilar, but they're separated into two channels, basically. So they're sitting on top of each other, but not directly connected. And the other channels are connected in series.
Okay.
As you can see. And that's not sawtooth, that's square. I was reading the app wrong.
So one channel
There's a strong
is
electromagnetic
one
field
wrap,
generated.
and the rest of them are all in series.
You said what? What, Mike?
So one channel is in one wrap, and that's the one you're giving it the energy, and the rest of them are in series taking the feedback.
So the two channels that are not connected are both in series. So you got 12 wires in series producing channel A. That's the input. And then you have 12 wires in series that are not connected to the other 12 producing the second channel. That's the output. That's
your
basically
secondary. Yeah.
Yeah, it's some kind of inductance that's happening because the two channels are not directly connected, but
And
they're twisted together in this bundle very tightly.
Are the
I
second
think I over
12
tightened it.
Are the second 12 wrapped together?
Yes, they're all wrapped together, all 24.
I mean, what I'm asking is,
Yeah.
do you have two pairs of 12 wires? One set of 12 wires wrapped together with another set of 12 wires wrapped together, and those two pairs wrapped together to make your bifilar? Is that what's going on?
Yes, exactly. And then you just separate the leads into two channels,
And
right?
and you're left with 4 wires in the end.
Yes, you're left with 4, 2 input, 2 output, or however you want to hook up your circuit. That's how I did it, replicating the PoE vortex coil. There's other methods where you can use more than 2 channels. I'm going to experiment with 3 channels in the future and see how that works. But you can see like there's a strong electromagnetic field generated at the low end of the frequency range.
Put our magnetic pole detector in there.
And you put the regular pole detector in there, the regular one on the hinge, and it detects. But you put the magnetic one, which works and detects. I show you it actually working with a little magnet, a neodymium magnet, and it doesn't detect anything. And it's very wild. And then depending on the frequency, I determine and the power level, you can actually detect a north pole, and I've detected a south pole as well.
So you're using the second pair, just to power things. And
yes, I'm using channel A to power.
To power the device, and the channel B is just to power devices.
Right, the load.
It's clearly got an electromagnetic field. But we are not picking up any
So Ben, are you you've wired this, it's like one long wire, right, to make up both directions of the coil winding. So you'll go one direction first, and then you'll reverse it and then go the other direction. So all 24 wires are like Litz wire. They're all wound together in one bundle. And then you separate them out into 2 channels, and then you'll connect. You'll take 2 channels, and then you'll connect all the wires for the other strands in series. Is that right?
Yes.
How is Litz wire
and then
exactly?
you'll see.
Are you doing it from the channel A into channel B, or you're separating them out into 2 different coils essentially, although they're intertwined?
Well, it's both. So you are
the other
separating
wires
it. Yeah, you are separating it into. They're basically 2 coils in here, and it's wrapped into one.
Yeah.
So you have one binding of wires, one bundle of wires that's separated into 2 coils, basically. And then depending on your setup, you can have channel A be the input and channel B be the output. But in the Nunez method, you have it crisscrossed, where the output of channel A is actually the input of the load. And it's a different way of setting it up. But depending on the setup,
Do you need a diode to make? Were they using a diode for that?
I believe so.
Yeah, you would have to. You would have to be able to do that. Yeah, you can diode it back to the.
I'm not sure. Like I can actually, let's look at the circuit real quick, as I have it up here. Where is it?
Was it the open circuit or the closed circuit?
So no, actually, this isn't actually the good design. I have a fuller diagram I can bring up. Give me 1 second. It's in my do-it-yourself guide.
Well, it's AC, so probably don't need a diode. because the AC has a positive and a negative. It's got no polarity.
Okay, I'm gonna present this. Stop screen. And then we're gonna present this do-it-yourself guide that I put together. And this has a couple of better
Groovy background. What's that? Is that the is that background like a portal or something? That gold.
You said what, Mike?
The background you got there. The behind the page.
Okay. So this is it. This is the proper diagram that was very hard to find. Here you see that I think all they use is a capacitor, and they recommended a high.
Okay.
High
A
voltage
capacitor will not pass AC. It will convert AC to DC. An inductor will pass AC and not convert to DC. Just thought I'd throw that in there. So that capacitor will take the AC signal. If it's not, I can tell you right now, that capacitor is not a polarized electrolytic capacitor. It's an AC capacitor. I'm positive.
Well,
Because
in the
you're
description,
feeding it
they
AC.
recommended a 200 or 2,000 volt hot HV capacitor.
Yeah, that's definitely not electrolytic. They don't make them that high voltage electrolytic, that high of voltage. That's AC capacitor. So that means that capacitor could take the flipping polarity of the AC signal and convert it to DC for that
For
light.
the
I
load?
guess. Yeah, for the light. Yeah.
Yeah. Huh. Yeah, because that's what would power the light more efficiently, right? The DC power.
I think the capacitor would take half the AC signal and pulse it and make it a DC like that, making that light get its frequency through the halfway pulse.
But yeah, here you see the only thing that they're using
is
a
second capacitor. I don't know if it's put in parallel there, or in series, but a second capacitor might rectify the whole AC wave into a solid DC line. And that light would not.
So the output of channel A is connected to the positive of the load, and the input of channel B is connected to the output of the load, and the output of channel B is connected to the amplifier, which is very unusual way of hooking up the circuit here.
Well, it's just putting the signal into the coil from the other direction, right?
Yeah, and that's the idea, is reversing it. And
Right, so the
you
AC
want to have the
capacitor
energy
does
going
that.
one way and the energy going another way.
The AC capacitor does that because it's AC. It could go both directions. So you could polarize AC one direction on one cycle of the wave, and then when that cycle of the wave is going the other direction from your source, the AC capacitor will then dump the other half of the way the other way, kind of thing. I don't know how to explain it, but yeah, AC capacitors, 15.15 microfarads. So that's a high frequency right there, low capacitance. And I see it says, wait, don't move. I was looking at that. Frequency generator ideas, Android. Okay, 12 hertz to 80. Frequency generator. You got two generators here. Why? Oh, one's the closed circuit. Okay. You're talking about the right one on the right now, right? Okay.
Right. And then
so that's
again,
the stereo amp, plus and minus. Your output is the load. The other two wires. You have 4 wires on this whole thing. The 2 are the in, and the other 2 are the out. That's the 4 wires on your coil.
Real quick, for Ian, if anybody or Ian or anybody wants to try to replicate these experiments that I did, that are just basically replications of the Nunez experiments, the required increments for tuning your coil would be a resolution of 1 hertz. So you see But what I found was actually tuning it around, like using a 100 hertz increments was more efficient, because it took, it takes forever to try to find that sweet spot, but it was a little bit easier using 100 hertz increments for me.
So Ben, you see the
And were you
where the
were you using
capacitor
a
is?
were you using a scope to find it?
No, I didn't use an oscilloscope at all. I just used multimeters to try to look for the spike in output power, because that's basically
Right.
what the Nunez descriptions call for. Look for a spike in output power, and that's what I did. Basically, just followed their instructions to a T, and it worked. You find that sweet spot, and it's an initial sweet spot. And like you said, like I think as you'll see in the guide here, there is a theory of mine that aligns with yours in the phi ratio and the harmonics of it. You'll find the initial resonant frequency, and then it seems to be in using the phi ratio as an octave of that initial, you'll find the next sweet spot, and then the third harmonic, or the second harmonic, or whatever, the third sweet spot, that is supposedly the range for the Nunez method, which basically supposedly times the output by 10. And I did actually witness that in very, very small increments in the microvolts or millivolts. I forget what the increment smaller than volts is, but it did times the output by 10 at a very low range. It was like 12 on the input and then 120 on the output, which is very, very cool. But so it does work.
Right. And it's all usable energy, right?
Yes. That's why I hooked
Right.
up the circuits. And I do have if you look at some of the live streams that I have a reference circuit up there as well to show you, okay, so the stereo amp receiver is outputting the same amount of power for both, because it's a surround sound system, you can use multiple channels. So it's outputting the same amount of power to each channel. You can use one channel for the coil, and what I did was use the rear speaker channel for the reference circuit. So you can actually see visually how much power is supposed to be going into the system and how much power is actually coming out of the system. And the fan spins faster, the lights are brighter when it's in that resonance range, and it lines with the multimeter. But outside of that range, it's lower on the output, which is very incredible. Like when you think about it, that's pretty cool.
Yeah, it is. I mean, so you're obviously using a power amplifier and using your phone for the signal generator, but
Yeah, phone or
and then
laptop,
passing
whatever.
right. Okay. All right, interesting. So, and then but the amplification is probably is that attributable to the actual power amplifier you're using to put the input signal in?
Yes. So
So
you can
you're
actually,
measuring it going in and coming out, right?
right, and the amp actually is kind of like a poor man's makeshift power supply, because you can control the power coming in with the gain, so the volume knob essentially, and you can kind of control it that way. And if you have a multimeter hooked up to the output circuit, the reference circuit, you can see exactly how much power is supposed to be coming out of the system, and it does kind of align with the number. I think it's like 5 is around 5 volts supposed to be coming out of the system, or something like that, 5 on the knob.
All right. Yeah, it's interesting. Yeah, I'll definitely give that a look.
Yeah, it's a very easy. Yeah, it's very that was the idea, that they wanted to put out a very easy, replicatable, and low cost system that you can try yourself. And just to be aware, people, this does supposedly, the Nunez method put out high voltage, so be careful and be aware. Like know what you're doing, and be safe.
Yeah, but if it's a power amplifier, though, the signal coming out of it is polarized, right?
Yes. So you have a
Okay,
you
so
have a
it's not AC then, right? Am I right to say that? In which case,
so
that
it's
capacitor down at the bottom is probably like a smoothing capacitor or something
yes,
to
that's the idea,
rectify
is
the
the
circuit to
capacitor is
start
supposed to
with,
smooth
right?
out the signal. Yeah, the capacitor is supposed to smooth out the signal, but the
Right.
signal itself coming out of the amp it's DC until you put the tone into it, and then it modifies the signal to be AC. And
Okay.
right, but the capacitor does smooth out the signal because, you know, again, you're probably getting some kind of filtering from your, depending on the amp that you're using, you know, so and all sorts of different noise that you have to filter out for the signal. But yeah, that's the idea, is to smooth out the signal with the capacitor, and they do recommend a 2000 HV capacitor.
Yeah.
Hey, real quick, Ben.
That's
Sean wanted to know where he gets a copy of this.
Oh, it's in my do-it-yourself guide, so you can get that on my channel. Here, I'll post a link in the chat here.
So what do you think, Ian? We got a whole bunch of stuff going on between everybody, huh?
Yeah. It is. It's great to see. It's just a matter of wow, just getting the time to get everything done. It's
Yeah.
crazy. But it's great. I mean,
It's a remarkable time for sure, but yeah, the timing is an issue for me as well.
yeah.
Well, what I like
That's
is
good.
people are kind of doing some of the same experiments, but there's just enough difference where you can cross-reference, you know what I mean, between the different ones, and then try something different once in a while.
Absolutely. Hey, all right, just getting your.
Oh,
right.
yeah.
Got
For
it.
my okay, I drew a
Nice.
small diagram here. I don't know if you can pick that
Hold
up
on.
on camera.
Give me
Oh,
one
here,
second.
let me stop screen. There we go.
Let me go to present.
So
Go ahead.
this here is a 2N3055. Then you got your neon that goes from your base to your emitter, and then your signal generator. Positive goes to the base, your negative goes to the emitter. Your power supply, positive is to the collector, and your negative goes to the coil. Then and it goes to the primary, the input on the primary. Then the output on the primary goes to your negative. So not only am I running this negatively biased, when I turn the pulse on, it fills the coil. And when I shut it off, that's when it releases. So that's the circuit. And this part here is where John Bedini would run his charge battery from. So it's a diode to a capacitor. And then from the capacitor, I usually run it to a capacitor bank or a secondary battery. I'm sorry if you guys are picking up the background here.
It's okay. I'm just happy to see this. Can you hear us?
Sorry about that. Go ahead.
Can you hear us?
Yeah.
Yeah, I'm just happy to see this. So, okay, what's the neon light? Is that just a draw? It's just it's like pulling a little energy out. Is it like a cold energy pull?
Okay, so the neon is to stop the 2N3055 from blowing when there's too much current in the system. But that doesn't light up unless I'm in resonance, and that current, I believe, is scalar. Now, John Bedini references when this light is on that it's a scalar pulse or a negative pulse or etheric or quantum vacuum, call it what you will. But when this turns on is when his system is getting that excess pulse factor. Now,
So it serves two purposes. It's an overflow and it's an indicator.
absolutely. And I'm going to tell you a little something I do with my circuits that I keep out of the videos for the most part. So here's a little tidbit that you guys should try and use as much as possible. If you wire your circuit like this.
Nope, cutting out a little bit.
Okay, so can you hear me now?
I can hear you.
Okay, so when you wire your circuit this way and you come from a diode off your collector to this capacitor, instead of going to a secondary battery for charging, go to a capacitor bank. And then that capacitor bank acts as an overflow for your circuit and your coil in its entirety. So when the circuit's being pulsed, because the way this circuit is set up, the coil fills this capacitor bank like that. 200 volts. You can make a larger. I have a 250 volt capacitor bank, and it charges it in the blink of an eye. And then this goes into resonance and starts igniting. The neon goes off, and my coil goes insane. So if you use this here as a capacitor bank, as sort of like a backup power supply for your whole system, it actually feeds back into the coil, and you can replenish it faster than you even notice it's going into your coil. It's just the way that the circuits run. And this little end part here with the capacitor bank, I'll show you when I do the presentation, goes to how I'm using it for levitation.
Oh, come on now.
So
Nice.
I hope you guys all got that, and I hope you can see it. The coil's in green, so it's a little light. The bifilar, the secondary, comes off here. And in this circuit, I just put a capacitor here so that you understand that this is pulse. So when your primary is pulse and your secondary feeds, it fills up. This has to either be a pulse or it's got to go to a battery. But it has to, if it's going to a battery, it's got to have a diode. Or you can use this secondary, ground one side, leave one side open. But prepare yourself for the sparks that come after, because your whole room's going to go static. So there, I let out some golden apples there for y'all. I hope you take it and run with it. I hope it works for you. And that's the circuit. So
That's so amazing.
Nice.
this, I don't know if you can see this.
Oh, hold on.
Yep.
This is going to be the next stage. I don't know if you can capture the inside there. You see how it's layered?
Yeah, we see it.
Okay, so here's the back side. And then
Right.
it's layered in such a way it looks like a reactor. So it's wound in such a weird way. But on the inside, it forms layers. So there's a wrapping, and then if you can look, there's a double wrapping, and then there's a triple wrapping, like a Stubblefield coil, but it's all on the inside. And then the outside is uniform. There's a reason for this. I'm looking for a chemical reaction due to the static electricity created by the fields in this coil. So that's one of the next projects that we're going to work on in the future. And we'll do some live experiments with this thing, because I put these coils in water, and I'm going to say that there's anomalies that even I don't understand that require other people to see so that they can help me understand what's going on, because it's that kind of crazy. You know what I mean? So yeah.
Yeah. Gerald,
Nice.
you've given us a lot to think about, and there's a lot to unpack here, but you have given us a lot of cool videos and cool demonstrations of real life devices that we can actually apply to our everyday life. So it's not like, some abstract idea. You're explaining how you can extract energy from the vacuum,
I believe I am. I mean, I can't prove that yet. It's going to take to get into your hands and you guys to do the experiments to prove it. Right now, pardon the expression, but I could be talking out of my ass. I'm not, but until you get this in your hands, how do you really know, right? So I try to explain to the best of my ability the truth that I know and have experienced, so that when you do get it in your hands, you go, wow, that crazy nut actually had it. That kind of thing, right? So yeah, it's to do the best I can to get it into everybody else's hands and to think, right? Making people think about this is the most important thing, because what happens
Thinking,
if
yes.
the next Albert Einstein comes out of playing with this stuff? I don't know that. And that could help everyone. I don't know. So just making people think and working on this, that's joy in my heart. And joy is the thing I'm doing this for. So let's go for it,
Great work.
everybody.
It's great work. I love what
Nice.
you're doing, Gerald. Continue up the great work.
Hey, don't kid yourself. You guys are doing some great work too. We're all doing the same thing. It's all based on the exact same principle, just in different ways. We're coming at it from different angles. And that's freaking beautiful, because then the more angles we come at that same principle, the more people can understand it. The garage guy, the physicist, the scientist, the doctor, whoever. That's what we want to get at, right? That's my
That's it. Just use some good old common sense language that everybody knows. Quit with the highfalutin. We'll just keep it easy.
damn straight. Hey, we can do the highfalutin just for the physicists, but we want to make sure that everybody can understand this. This isn't for the elite of the most prestigious scientific communities. Sorry, I don't mean to be a dick. I'm just...
You just don't like them at all. We know better, Gerald.
Yeah, I know.
Indubitably.
I can do voices. It's just sometimes it comes off as prejudice, and I'm not. I the least prejudiced person you can possibly imagine. I got beat up for the first 7 years of my life for being white. I know what the other side is like. Oh. So there's not a prejudice bone in my body. So when I joke about these voices, I apologize if it offends anyone. It's for humor only. Like my dad used to do this Irish voice, so I apologize to those that are Irish if this offends.
Well, hold on. His thing says blog Irish. Hey, it's not blogish. It's blog Irish.
There you go. Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marry's illegal. He used to do that a lot because he had a bit of Irish in him, so he used to joke like that. So I apologize if I offended anyone. I just had to do that.
Not at all.
Okay.
Your Irish accent's better than mine.
Are you Irish? Is that where you come from?
Yeah, I'm from Belfast.
Oh, well, tip of the hat to you.
Northern Ireland. Yeah.
Northern Ireland.
Yeah.
I see. Yeah.
Nice.
Sorry, I knew a lot of people growing up from different backgrounds, so I kind of picked up on accents. I like to have fun with life. It's short. You never know when it's your last day, man. You know what I mean? So,
yeah.
Hey, you never take life too seriously. You'll never get out alive, right?
so true. So true. You have to have fun with it, man. You have to laugh because, you know, we said, it's, you never know when your last moment is. Be standing here one day and, the next I'm not. That's why I'm trying to get this out. And part of my dead man switch, if I do end up passing away, I hope that I can put in the right code before I do, or everybody's getting it no matter what. So no matter what happens, this text coming out, right? And there's a treasure buried somewhere of a copy of all my coils, a copy of all my notes, my book, everything in the dirt, hidden somewhere. And there's a treasure map. So, I mean, if I pass away, good luck to those that are going for it. I hope you find it and it does you good, you know?
Now we got Oak Island Gerald over here. We're going to be digging in a hole.
There you go.
Filling with
right?
water.
Hey, old school. Old school, man. There's nothing like old school. It's the best school, right? How are you going to find it? You going to follow me to where it is? I'm never going back there again. You know what I mean? So hey, you do what you got to do, and I take precautions. So
Oh, please do not put a lost ship over there by it, so we get distracted.
ship in a bottle, just for those that find it.
Such easy
Yeah.
distractions going on around us. I just
There you go. Well, there's a couple nest eggs in there. Let's just say there's things that nobody's seen before that are sitting in that trunk in the ground. So there'll be something to look for if I do end up passing away one day and somebody looks for it.
Now, hold on. Are we going to be looking for multiple trunks here? Because you keep updating your stuff, from one presentation to the next. So we looking for multiple ones here?
No.
We're never going back.
No, there's some coils that'll never be in there because it's done. And I'm never going back there. It's sitting in the ground. I've forgotten about it. You know what I mean? Like that kind of thing.
That's what I'm saying. We're looking for multiple treasure chests now. You'll be digging holes all over
Till
the
somebody
yard.
stumbles upon it, like Gollum.
Well, my wife has instructions to give everything I have that I experiment on to certain individuals. So it'll get out there no
I'll
matter
end
what.
up digging up the one with all the broken stuff in it. And then blowing it off the table just because I use high voltage on everything.
That's okay.
And I'll say, Gerald, did it work?
You'll have the instructions to build a new one. So it might take you a little bit to get into the winding, but you'll get there. I don't know about something like this though. This thing was different. It was hard. I've had some hard winds before, but this one was.
Hey, does water go through it at all? Or what does it do in the water? Just somebody asked earlier.
Does water go through it?
Like through the center of it? Yeah.
Oh, I could put a tube with water through it. I put the whole coil in water and pulsed it.
So what is it doing in the water? Is it making pulses or what?
How do I explain this? You know how you hear the ringing from a coil running? I'm sure Ian knows what I'm talking about. You can hear that high-pitched ring.
Mm-hmm.
Well, when you put it in water, you're not hearing it. You're feeling it. It's like it's resonating the water in the bowl. And because that water's resonating, the water in your body's resonating. That's what it feels like. Does that make sense?
Yeah.
That's why I said there's some weird things, some crazy stuff that goes on with this. Right? And if I hit it hard enough, rather than pulsing it at like a regular frequency, say 432 or 528 or something like that, and I just hit the power with, say, one pulse, you can see the water go boom. You should like dropping a pebble in the water. So
Gerald,
there's some crazy stuff. Sorry?
You should put LEDs on it so it looks like an arc reactor, like a Tony Stark arc reactor.
I thought about that, but it's too deep though, right? His arc reactor was small, like it was maybe an inch. This is, I think, 2.5, 3 inches.
Still, I seen somebody try to replicate it, and they're like, it's not going to output more than it inputs. At the beginning of the video, and you really have an arc reactor here, basically.
Yeah, kind of. Yeah, I just don't have the resources that Iron Man did. I mean, we'd already be flying back and forth to the moon.
Hey, but the general principles are very easy, and that's the idea here. We're trying to relay to everybody in the general audiences. These ideas, they've been around for a while. Tesla did it, Bedini did it, lots of inventors did it. It's not that hard to understand.
Nope.
It's just a couple of basic fundamentals.
If it was up to me, we would figure this out, and every one of us would come out all at once with the same thing. That is the best way to do it. Nobody gets the glory. Nobody gets the fame and fortune from it. I don't want it. And if we all came out with it all at once, then it's just a tech for the world.
Right. The prize for me is leaving the world a little bit better than I came into it. You know what I mean? Like that's the prize for me.
I'm going to build me a Tron suit and just put your coil right on my back here. Use it as a discus. I'm going to light up my whole suit with it.
You build a suit. I got a special coil for each of your hands. And I got one for your chest that's huge. Okay, so let's make it happen. I'm in. I just don't have a 3D printer to get this stuff done. Okay? That's what I'd be doing.
I could do an artificial intelligence interface for you too.
You know what though? You don't need artificial intelligence. I think we as people are smarter than any AI out there. I just think that AI has a better organizational skill and recall system than the human brain. If we have that,
for sure. But what I mean by AI interface is just me talking to him. It's like, hey,
yeah, I get what you're
artificial
saying. Yeah.
intelligence interface.
Yeah, I hear that totally. I love this stuff, man. This tech's amazing stuff, and I appreciate you guys giving me the chance to share it. So, just wanted to say that.
Roll on Friday though, huh? That'll be
I'm working for it. I'm telling you, I got one more catering job to do this week, but I don't think that should get in the way of me finishing my work before Friday. But
so when is the next APEC?
I shouldn't say it that way. It doesn't matter. I was about to say it some other way. I'm sorry. What's that?
You said Friday's your next presentation?
Well, I'm gonna do the presentation on Nathan's channel, your channel. We'll do a live, right? And then I'll do the presentation. Yeah.
Which day you want to do it?
Okay.
Because we could do it on the weekend, we could do it on Mondays or whatever, whichever one.
Yeah.
You want.
Yeah. Well, if I don't get the prep work done for Friday, then I'll email you and we'll arrange exactly when we're gonna do it. But I want to do it immediately, right? Like as soon as possible. But I also want to do it with a live demonstration. I don't want to be these guys that puts out a paper and you got a nice PDF and that's all great and everything, but I'm a hands-on kind of guy, right? Give me a wrench, give me let's get it done, right? So I imagine
I'm a visual learner myself.
Yeah, see, and I imagine there's a lot of other people out there that are like that too. I mean, this science is easy to be done. It's just
I've always been under the impression that some of these people, they're not going to believe it until they see it with their own eyes. You know what I mean?
Some people won't even believe it when they see it.
Right. But we'll turn a few.
Hopefully. There was an electrical engineer friend of mine when I started out in all this, and he seen what was happening, and he went, you know what? That's impossible. I can't explain it. Therefore, you're wrong. And I didn't talk to him again, ever. He was just mad at me. So I don't know what to say to that.
You get a lot of haters, man. You get a lot of haters.
Well, you get a lot of people that don't understand and they don't want to understand. They come up against a brick wall. And like Ian had mentioned earlier, their whole life's work is based on it. You get some guy like me coming along and saying, you're wrong. Well, I don't think they're wrong. I just think they came at it from a different angle, and we came at it from the right angle. We're all headed towards
someone
the same
like that. You're never going to convince,
Unfortunately, no. Like a physicist, you'll never convince a physicist because his theories, he writes papers, he's got a PhD maybe, I don't know. He's got to support his work and his friends' work. I get that. Peer review, teach your own, but I'd much rather give it to everybody. That's my peers, not somebody with a PhD stating that they're smarter than me because they have papers. You got papers. Sorry, I shouldn't do that. I apologize.
Do that.
But
if it works, you can't argue with it, right? If it works.
That's right.
And if it doesn't, hey,
you just gotta study it and figure out how it works at that point,
And if it doesn't, I'm eating my own shoes. You know what I mean? Because I'm wrong. Well, then I'll be wrong and I'll admit it. Maybe I'll get some salt and sugar with this sucker. But until that day comes, I'm still pushing out what I can push out because that's what I'm seeing and experiencing. So yeah, I'm gonna put my shoe back on. Yeah, so that's where we're at. I mean, hey, physics, I think they were doing great for the longest time, and then it was like they were headed down the path of truth, and then they went and started following a narrative. And it's not their fault. It's more like we talked about earlier. they go where the money is, and the money is being directed in certain ways to keep them away from experimenting with this stuff and finding out what's truly going on with electricity. So that's my opinion. If I'm wrong, I'm wrong.
Oh, I agree with you for sure. Yeah.
Mm-hmm.
Hey.
So this has been an amazing stream, but I'm getting the stink eye over here.
Yeah, we're all about there, man.
Yeah.
Yeah, I'm gonna
ready
end my
too.
stream in a few minutes.
Hey guys, anything you need to plug, anything going on, go ahead, one at a time. Let it out.
Go ahead, Ethan. Or Ian, I'm sorry.
No, I'm good. I'm just waiting for Friday.
We're all
whenever.
waiting.
I'm waiting too, guys. I'm sorry.
He's waiting.
Should have been done months ago. I agree.
We don't have no empathy for that. We know you're the one holding back, so don't be doing that.
All right. I agree. You have to wait. No.
All right, Ben, what do you got?
Oh, so everybody check out Beneficence TV. That's my channel. And I just put up a 55-minute long video on time dilation effects occurring within the thunderstorm generator. It is a fascinating video. It's highly produced. It's fun. It's funny. It's interesting, entertaining, and highly educational. And I'm going to put the link in the chat. I highly suggest everybody check it out. It's a fun watch. So that's what I got.
Awesome.
Nice.
And I'm Gerald from WP Enlighten 4 Truth. 2. Not the first one, the second one. The first channel was hacked. So please come subscribe. Let's get those subscriptions up there. And I had stated prior on a live that if I hit 1,000, I'm going to put out a tutorial on one of the coils on how to wrap them and build them. So let's get it up there.
Hold on. Ben, put it in the chat real quick. Put it in chat. Let's get everybody in there so they have it. Okay.
There you go.
So put it out there before everything comes to an end. Yeah, no, we got to get to that 1,000. I'm going to do videos every day if I have to get you to 1,000.
Well, it's funny you say that because I'm going to start pumping videos out like big time. 5 a day if I can. I'm going to pump them out. So we're going to get some info out there and see what happens.
Yeah, because you know what? I can't wait because, hold on. We've been waiting for this presentation for 2 months. Now we have to wait a little bit more and wind this thing up to build our own. Okay. No, I know you're going to hand them out, but like all the rest of the people on this panel, man, I want to build my own.
Yep.
Okay. And I want to go through the process, and I want to screw up, and I want to have all the bad things happen so I don't ever do them again and don't ever question them.
Absolutely. I want that for you too. That's why I want to give you a coil so you can blow that one up, and then you have to build your own.
He knows already. He already knows I'm going to blow it up.
Fry it and find out, man. That's the saying.
That is a saying. I'm gonna put it on the hat.
To be a shirt, fry it.
I fry
or an apron, a cooking apron.
Because I deal with a lot of high voltage, so even if it's just sitting next to me with the statics going off, it blows up on me. I fry everything. I don't mean to. And that's why I just go outside now. I got my little cart. Tired of everything blowing up on me.
You're just always statically charged. You touch something and just blow it up.
But think of how much you've learned, though. You know what I mean? Like, I go by this saying. Well, there's 2 sayings I live by, but one of them's verticos veritas, which is Latin for speak the truth is a way of life, right? And the other one, well, stay true, stay you, right? So when you're doing all these experiments, just remember, be careful. Try and keep one hand in your pocket because, like Nathan says, you're going to fry it and find out.
Yeah, the one hand rule. Exactly.
Yeah.
Gotta have that pocket pull rule. Never can yell at anybody about that again.
High voltage is insane, but I love it.
Oh,
yeah. This has been great, guys. I
appreciate
the time.
Yeah.
That's everybody.
Thanks for having me on as well.
Yes, definitely.
Ian,
awesome,
Ian.
I appreciate your work and I appreciate you looking at mine. That's like I said,
Hey, it's a great thing.
I
Looking
can't
forward
wait
to it.
till you build your own and not get electrocuted like I did.
No.
And we want to
All
give
right.
a big hand
Thanks,
to
everyone.
Nathan for our host here. I want to say thank you for bringing us all on. And then again, one to Ben. You're doing great work. Appreciate that. Right?
Oh, man.
If you ever come to Canada, I'll give you an amp. I have like 6 of them sitting in the other room. So
Hey,
Yeah.
thank you for everybody in the chat. You guys are awesome today. I tried to put up as many comments as I could, so did Ben. So we're working on it. Thank you guys
Absolutely.
all for showing up today and having a good time with us. Absolutely amazing show, guys. Thank you, everybody, for being here.
Yes, thank you.
thanks,
Thank you,
everyone. I hope you have
Ian.
a great
Thanks,
night.
Gerald. Thanks, Nathan.
Thanks.
See you
Have
guys.
a good night, everybody.